So here we have a problem that asks us to solve using power rules, and we have this equation. So to solve, we want to get the x by itself, and we need to use certain power rules in order to do that. So first of all, if we ever have a fraction that has a negative exponent, we can use the rule of if you have a over b to the power of negative c, that is equal to, we flip the inside fraction b over a and change the sign of the exponent. So it becomes b over a to the power of positive c. So let's use that rule on this first fraction. We'll flip the fraction to make 25 over 9, and then change the exponent sign to positive 3 over 2. So that's the rule for this fraction. I'll just bring down the square root of 27, the square root of x over 27, which is equal to, now we have another fraction that also has a negative exponent. So we can use this same power rule to flip the fraction on the inside and change the sign of the exponent to a positive. So it's just a positive 1. Technically, we don't even have to write the exponent of positive 1, so I can just go ahead and delete that. Okay. The next thing we want to do is, let's go ahead and do a little bit of simplifying. Let me give myself a little more room. Let's do a little bit of simplifying. If we have a fractional exponent that has a denominator of 2, that means we can take the square root of that number. So, for example, the square root of 25 is 5, and the square root of 9 is 3, and that will get rid of that denominator of 2. So we're just left with the numerator of 3. And the rule that goes with that is if you have, just say a to the power of m over n, so to a fractional exponent, that's the nth root of a to the m. So basically the denominator of that fraction becomes the radical, and a 2 radical means a square root. So that's where that rule comes from. Using that same m over n, a to the m over n is equal to the nth root of a to the m, we can use that same rule but in reverse and say that because there's an understood 2 here for a square root, we can write this numerator as x to the power of 1/2, because there's an invisible exponent on the x of a 1, and there's the invisible radical as being a 2. So just bringing down the rest of that, and we can simplify just a bit more. 11 squared is 121, and 3 cubed is 27. All right, so continuing, we can now just do 5 cubed is 125 over 3 cubed is 27. And then let's bring down the rest of the equation. From here, now we've simplified it quite a bit that we can start trying to isolate our x. So let's move the 125 over 27 term to the other side by subtracting it on both sides. And when we subtract fractions with a common denominator, we can subtract the numerators and the denominator stays the same. So these two fractions cancel out. leaving us with negative x to the power of 1/2 over 27 is equal to 121 minus 125 is negative 4. So that makes negative 4 over, and the denominator stays the same, stays a 27. From here, we can get rid of our fraction by multiplying both sides by 27. So the 27 on top cancels with the one on bottom. We also have a 27 denominator on this side, so those will cancel as well. And now we have negative x to the power of 1/2 is equal to negative 4. We can multiply both sides by negative 1 to clear the negative. So that makes x to the 1/2 is equal to positive 4. And the last thing is we want to get rid of this 1/2 exponent. We can do that by raising both sides to the power of 2. And the power rule that that shows that is if we have a to the power of m also to the power of n, that's equal to a to the power of m times n. So if we multiply the 1/2 by the 2, it just gives us a 1. So that's getting rid of our exponent, making it just a 1, which is what we want. And 4 to the power of 2 is 16. So our final answer would be x to the power of, x is equal to 16. Okay, I hope this video was helpful for you. If you have any questions, feel free to leave those in the comments. And if you like this video, then please leave a like and subscribe to my channel to see more similar walkthroughs of homework problems. Thanks for watching.